the structure is an entity that can be treated as a whole. So assuming we have the same structures here, two integer, right? One float and one char. And SAM1 and SAM2 represent, right, two different instances of the structures in memory. The very first operations that we want to consider is copying one structure over the other. And in fact, this could be done by way of SAM2 equals SAM1, assuming that you want to copy the content of whatever's in SAM1, right, to it. So this is the R value, right, into an L value operation. So rather than assigning individual members, right, and copying, SAM2.x equals SAM1.x, right, and so on for each individual unit, you can treat the entire structure as a whole, right, and simply just use one assignment operator to copy the entire thing from one end to the other. So this is one very special property about a structure, and you can use assigned operator to copy, okay, one structure over the other. And it's interesting to know that since we can copy one structure into the other, is it okay, right, if we were to, do a comparison of the two? Now, this is very tricky. Different hardware has different slack bytes, and in general, we can't just compare, whatever's in memory, right, bits by bit, byte by byte in memory. So this is sometimes, and I would say most of the time, not allowed. In fact, you may not be able to get the results you need. So we don't compare two structures. We can copy one structure into the other. Comparisons, on the other hand, requires a certain data, right, such as integer, floating point numbers, etc., to be aligned on a word boundary in memory. So the scope of this is beyond, what we are covering here. The other operations I would like to consider is creating a pointer to a structure. So assuming that we have this structure called sample, and the sample is essentially just a block of memory, right, in space. And this sample has a reference, and this is SAM1, right, in memory. And we create a pointer that points to it, as you can see right here, right, by way of doing this. So now this pointer points to the entire, right, SAM1 object. So it's almost like having an integer pointer that points to the memory address of, something, and assuming that this something is, is 3, right? So there is memory address associated with this object. So SAM1 here. If we were to dereference this pointer, you get back the entire SAM1 object. And once you have the SAM1 object, right, we use this selection operator, this dot operator, to get the respective variable that we need, right, or field we need. We do the same thing, right, with dereferencing pointer and then dot y. So we must remember to include this parentheses here, right? We don't want, in fact, this PTR to dot into y, right? And then you dereference this entire thing, right? These are two different operations, okay? There are two different operations. So in order to fetch individual fields, right, using a pointer pointing to this object, right, this SAM1 object, we will need to dereference itself first, and then we use the selection operator to get its respective fields. And in fact, doing this, right, is the same as if we just used the object directly, right, SAM1 dot x. So these are equivalent. And also remember, PTR is the same as the address of SAM1 here, right, as this illustrates, right, this line. And what is not shown here is you can actually use pointer and this indirect pointer operator. This indirect selection operator can get you from pointer to the, right, respective fields that you need, but you have to use this, right, arrow sign, right? This is a dash, right, plus a greater than sign. It is placed immediately after the pointer identifier. In your pointer chapter, we talked about this property, right? Whenever you have a pointer pointing to an object, in order to access that object's individual member or field, you would need to use this indirect accessor or selection operator. Another way of accessing these individual fields is use the indirect selection operator, which can only be applied on a pointer. So PTR is the pointer to this sample struct. You would use this indirect operator to access its member like this. Now, this is a dashed line, gradient sign, right? This is the arrow we're talking about here, as opposed to this dot operator when you have a non-pointer structure. So with pointer, PTR, you use arrow sign X. You can do the same thing with PTR, arrow sign Y, right? PTR, arrow sign T, and U as well, right? So this is not a way of accessing member variables or fields using the pointer route. And in fact, this is what we are talking about earlier, right? If you have a pointer, you use the indirect selection operator. If not, you can use the direct selection operator, but you have to dereference, right, this pointer first back into the structure and then use the direct one to access the field name. So this field name is the XY, right, TU that we saw from the previous slide. So this is showing the correct way of doing things, getting the correct reference or the data members, data variables or fields or what have you, assuming that PTR is pointing to a valid data structure here, right? This data structure is the type def, right? Structure called SAM1, right? You dereference the pointer and use the direct access selection operator to fetch its member. Now, this second example, right, is showing what not to do. And in this case, PTR is not pointing to any valid data or dereferencing undefined structure, meaning PTR could be a null, right? PTR can also be pointing to a random memory in address, whatever this PTR was when it was declared, that you're running the risk of meddling, some other memory addresses that are being used or occupied, causing, issues. So there are three ways to reference or fetch the field, right? X here. We talked about all three of them. One is a direct selection, meaning you take the structure and you use the dot operator. The second way to do that is assuming you have a pointer that points to, right, this structure, you can dereference that pointer, which gets you back that SAM1 structure, right? And then since we're dealing with a structure, you can use the direct selections here, but the indirection here is that dereferencing operation we're talking about. So this will get you that X. And the third one is directly just take the PTR, which is a pointer pointing to a valid, right, structure in place. You can use the indirect selection, which is that arrow sign that we're talking about, to fetch the data member here. So all three are valid.